Hi everyone, hope everyone is doing well. So in this video tutorial, I'll be showing you how to design a model in Fusion 360 and then use a plugin, that is Fusion 360 to URDF, Fusion to URDF, and how to convert the model in Fusion 360 to URDF so that we can use it in ROS to map the environment and do autonomous navigation. So we'll be using this plugin. It's been around for quite a while now. To convert our CAD model into URDF. So URDF stands for Unified Robot Description Format. It is like a detailed description of our robot model which we do in our CAD, let's say in Fusion 360. So let's get started with the designing 3D modeling. So before starting, we need to keep a few things in mind. So before starting, this should be the orientation of designing. So the X should be in the top, Y, Z should be down here, and Y should be here. It is, if you design it in such a way that the robot will move forward when you drive it forward, because the X should point at the top. So let's draw a symbol. Say, let's draw a symbol square. So I'll create a 2-point rectangle, center rectangle, and I'll draw a square of maybe 200 by 200. Okay, so I have drawn a square of 200 by 200, and let's do one thing. Let's extrude it so that we can see it in 3D, maybe by 50 mm, that is 5 centimeter. So the operation is creation of a new body. So what will we do the next? We'll create wheels for the robot. So to the side we'll create the wheels. So I'll create a new sketch here, and we have center diameter circle. So if we zoom in, we can find the center point here. Just display place center point. So I'll click here and draw wheels maybe like 10 centimeter. I'll finish the sketch and I'll select it and extrude it. So I'll extrude it by maybe 25 centimeter. So the operation is not join. I'll keep it as a new body. So as you can see, a new body is created. Okay, so the next thing we need to do is we need to create one more wheel here. So I'll select body 2, that is our wheel here, and I'll click on mirror. And so we need to select a mirror plane for mirroring the object. So I'll hide our main body and select the mirror plane. So as you can see, the second wheel is created here, and I'll click OK, and the operation is new body. So our bot has a body and 2 wheels. So we have the 2 wheels here, but the thing is, the robot is below the plane. As you can see, this is our plane and the robot wheels are below the plane. So we need to bring the robot above the plane. So in order to know how much we should move the robot up, what we can do is we can construct a tangent plane to the wheels here. So a tangent plane is created, and what we can do is we can measure the distance from the tangent plane to the robot base. So as you can see, the distance is 25 millimeter. So what we need to do is we need to move the robot by 25 millimeters. So I selected all the parts and I'm moving it by 25 millimeter. So as you can see, this is touching the red line. So I press OK. So the robot is right now in the plane. Now what we need to do is we need to create caster wheels for the robot so that the robot doesn't fall down. So to create caster wheels, we'll create a sketch. So we'll select the base of the robot, and I'll create sketches here. So what I'll do is I'll create 2 cylinders, maybe 20 mm, and one here and one at the bottom side, 20 mm. Okay, so if you can see, I have created 2 circles. So let's do one thing. We'll extrude the circles. Let's select the circle and click on extrude. So if you remember, the distance from the plane to the base of the robot was 25, so I'll extrude it by 25, and I'll extrude the other one also by 25. Extrude and 25. Okay, so as you can see, our robot has 2 wheels and casters now. So but if you can see, the casters is not perfect. See, it is flat. So in order to make it smooth, to avoid friction, what we can do is we can do fillet. So fillet is a function here, and so we can make it nice and smooth. Okay, so we'll do it here also. Apply fillet, and so we have our robot here. It has 2 wheels and it has 2 casters so that it doesn't fall. So the next thing we need to do is we need to assign joints. Then we'll add a lidar for sensing, and then we'll export it to Fusion 360. Okay, so let's continue by adding sensors. That is, we'll add a lidar to the top of the robot. So we'll select this plane and we'll create a sketch. So our plane is selected, and we will draw maybe a rectangle over here. We'll select a 2-point rectangle, and we can create it maybe like 75 by 90. Okay, we have created a rectangle here. So we'll extrude it by say 10 mm, and it will be a joint. And we'll do one thing, we'll create a circle on top of that. So create sketch, I'll select the plane and then create a circle in the middle of this rectangle. So 72, that might be enough. So I'll click on extrude, and I'll create the lidar 25, and this will be a joint. And from here I'll extrude by say 20, maybe 25, and this is not a joint, I'll create it as a new body. Okay, so the lidar will be shooting its rays from this line. So we have our 2 wheels, casters, as well as our lidar sensor. So the next thing we need to do is we need to rename this as base link. This is a crucial part. This should be base link, and this will name it as right wheel, right underscore wheel, and this is our left wheel, left underscore wheel, and this is our lidar. Okay, so the basic sketching is complete. So the next thing what we need to do is we can assign materials to this robot. So if we click on the base link and physical material, a window will pop out and it will allow us to select what material our robot should be. So let's see, we'll create our robot base with ABS or ABS black. Yep, ABS plastic. So this might be enough. So drag and drop, and the whole robot is now in ABS, but what we want is we want the left wheels to be in rubber. So what we can do is we'll check for rubber. Yep, a rubber is available, so we'll assign the wheels with rubber. Yep. So the wheels are rubber and the rest of the body is plastic. So this, what if we don't do this, the friction won't be right. So if the friction is not right, the robot might have a tendency to slide around. So if we want, we can also give colors to the lidar, but this won't do any difference because in gazebo we need to um, assign colors by ourselves. So maybe we can make it blue. So it's downloading, and yeah, this can be made blue. Yeah, this makes our robot look attractive. Okay, so let's continue. So we have our robot here, and all the parts are in body format. All these are bodies. So the next thing we need to do is we need to convert the body into components. So I click on the bodies and create a components. So as you can see, it is created in components now. So the next is the crucial part. What we need to do is we need to join the wheels as a revolute joints so that the URDF knows there is a motion there. So in order to do that, what I'll do is I'll click on joint, and then I need to select what all should I join. So I'll click here. So sorry, that's the wrong way of doing. So first I need to click on the wheels I need to join. I'll click on the center of the wheel here, and then I'll click on the robot body. As you can see, the component 1 should be the wheel and the component 2 should be the base link. The other way will not work. So I have created a revolute joint here. You can choose the motion and type of joint from here. So if you click on play here, you can see and the wheel is rotating. I hope it's visible. Yeah, kind of. Okay, so I'll click on OK. So in the similar way we need to do for the other wheel also. So what we need to do is we'll first click on the robot wheel. So select joint, and then click on the base link. So as you can see, the joint is created, and if we click on motion and play, we can see how the tire is moving. Okay, so our joint is made. So what we need to do now is we need to fix the lidar. So in order to fix the lidar, our lidar is a rigid joint. So in order to do that, what we'll do is the same procedure. Click on joint, and then we'll hide the lidar, and then click on the point here. Okay, sorry, that's the wrong way. We need to first hide the base link, and then select the lidar first, and then attach it to the base link. So here the motion is not revolute, but it is a rigid joint. Yeah, so that's a rigid joint, and press OK. So we have two joints here, a revolute joint here, a revolute joint here, and also a rigid joint here. And if you notice, our robot is facing the X direction. So our robot modeling is almost complete, and let's see how to convert it into URDF. So in order to complete it to URDF, let's go to tools, and then add-ins. We can see scripts and add-ins. Here you can see a URDF exporter. I'll be pinning down a video on how to install the URDF exporter plugin. You can refer that, and I'll click on run. Okay, so it's asking me a folder. I'll select this folder, and URDF successfully created. So if we go and check out that folder, I'll just show that folder. Okay, you can see an unsaved description because I forgot to save the project. So let's do one thing. I'll undo, and undo. Okay, I'll save the project. I should have done this in the beginning. Let's name it as my robot. Okay, I saved it as my robot. So let's do one thing. Let's convert it into URDF. So URDF exporter, and run. I need to select the folder, and yeah. So the URDF is successfully created. So you can see my robot underscore description. In this, you can see the launches, meshes, and URDF of the robot. So we'll do one thing. We'll open up our Ubuntu workspace and let's see how it works out. Okay, so let's continue. So in order to press the URDF, I am not using my dual booted Linux version. I am using virtual machine, so that it's easy. I don't need to turn off my device each and every time to go to Linux and then test it out. So I'm booting up my virtual machine. I have Ubuntu 18.04, I guess. Yeah, Ubuntu 18.04 along with ROS Melodic installed. So let's wait until the operating system is booted up. Okay, so my Ubuntu desktop is set up. So what I'll do is, I have set up my King workspace in my Ubuntu desktop. So in the utilities folder, I have my robot underscore description saved here. So what I'll do is, I'll go to my King workspace in my Ubuntu. So here you can see my King workspace, src. Okay. So what I'll do is, I'll copy this into my Ubuntu desktop. So I'll copy and I'll paste it here. So there was some error copying the files, so I'll copy it this way, copy, and then I'll paste it into my King workspace. Okay, I've already pasted it here. So this is my robot underscore description. I have the launch file, URDF, and meshes. So if you take a look at on the URDF, you can see many things like this. So before doing anything, let's see if we can visualize the robot file in RViz and test if the joints are working. So let's see what's the name of the launch file. It is display.launch. Okay, so let's run ROS. So before that, we need to do a catkin make. So it is building. As you can see, our package is here, my robot underscore description. Yep, so the build is done. So let's launch it. It is ROS launch. My robot underscore description display.launch. Okay. Let's see if it's loaded up properly. Okay, perfect. So our robot model is loaded up, and let's test the joints. And if I click on a revolute joint, you can see the joint is moving. See, if you look closely, you can see the wheel is moving. So this was the robot orientation. Yep. So you could have also changed the joint names. This is now the custom rev1 and rev2. So this is also working fine. This is also working fine. So randomize center. Yep. So our robot model is done. So the next thing we need to do is we need to add differential drive plugging so that our robot can accept command velocity, which is linear velocity in x and z direction, linear and angular velocity, and the robot should accept that, and make the robots move. The robot should move according to the velocity commands given. So in order to do that, we need to add gazebo plugins. So we'll do that in the next video.